Phase diagrams look at the pressure versus temperature and summarizes all the conditions at which a substance exists as a solid, a liquid, or a gas. So what you have here is the basic phase diagram. The lines you see are called equilibrium lines, and they're separating the two phases that exist on either side of the line. So the phases are solid, liquid, and gas. And so this line separates the solid and liquid, this line separates the liquid and gas, and then this one separates the solid and gas. So remember, that's called sublimation. Solid to liquid is melting, and liquid or freezing, and liquid to gas is evaporation or boiling or condensation. All right. At 1 atmosphere, which is our standard atmospheric pressure, we can define the normal melting point. So a solid will melt into a liquid. Anywhere along that line, it will melt or freeze. But our normal one, our standard one at 1 atmosphere, can be identified by reading the graph and finding the temperature at that particular pressure. So between the liquid and gas region, you can identify the normal boiling point. The critical point is found between the liquid and gas phase at the very end of the equilibrium line. And that's the pressure and temperature above which the phase cannot be distinguished. So this is where we get our supercritical fluids, and a lot of interesting properties really are shown above that point. So with that, you can have a critical pressure that you read that value from the axis, or a critical temperature where you read that value from the axis. And our last piece is a triple point. And this is the point where any 3 phases coexist, and there are a lot more complex phase diagrams that can have more than one triple point. So here's a quick slide with a blank phase diagram and all the things that you would need to be able to identify, or also read numbers from the graph and identify what is present at that particular time.